interesting day of discussion and presentations. My name is Kat Headley. I'm responsible for business engagement at the university. So it's quite relevant for me that I'm introducing a session on external collaboration. We've got 3 speakers to introduce you to, and then we're going to have a panel discussion following that, and there'll be lots of opportunity to ask questions. So I would encourage you to have some questions ready as we get through each talk. So I'll start by introducing our first speaker, who is Muir, who is a research associate in environmental engineering and climate change at the University of Manchester and a member of the Tyndall Centre. So I'll welcome you, Muir.
Are you able to hear me? Great, so thank you very much for this. Just as a sort of census, I thought I'd ask a couple of questions just to gauge the sort of room. Could you please put your hands up if you know what glass is? Okay, we've got some. Who knows what biomass is? Okay, well, this is better. Oh, sweet. Who knows what biofuels are? That's great, no explanation needed. Lovely. Great, so this project I did was short-term PDRA that I did alongside the submission of my PhD. It was 4 months, and it was all about decarbonising a series of glass furnaces across the UK. It was short, snappy, we got together. So the main things you need to know about glass furnaces is that they're really big, energy intensive, they're going 24/7. Some of them are producing hundreds and thousands of tons of glass per day, which is really energy intensive, keeping them always on. Right now they're using fossil fuels. Right now they're trying to think of decarbonised pathways to be able to reduce these emissions. The sector as a whole, they are wanting to reduce down to 80% of their emissions. They are a hard to abate sector, so they're struggling to get to zero there. But there are many different pathways that you do to decarbonise your glass furnaces. Basically, you've got fuel switching right at the top, biofuels, hydrogen, electrification, and material swappings. Our project, we were looking at fuel switching for biofuels, tailored to these locations. So, as everybody kind of knows what biofuels are, there's quite a few varieties around in the UK that we can build, be it a generation 1, generation 2, 3 or 4. For this project, we were only considering generation 1 and 2 biofuels, as these are the sort of resources that we have now. As the companies that we were working with, it's a company called Glass Futures. There's another slide on that later. They wanted pretty much immediate action. So going to algae and these other sort of new sort of biofuels wasn't a viable option for them. So what we did, we worked with Glass Futures here. So they are a consortium of different glass furnaces across the UK that wanted to decarbonise their fleets. You can see them there, brand new building, Glass Futures Centre, we went there. Big shout out to May from the business engagement team. We did a lot of promotional videos there, so they sent me with ill-fitting hard hats around the facility, taking videos, getting a bit of advertisement for the university. It was really good fun. But a bit of a description up there as well. But again, 4 months, do this project. We were able to design supply chains. So the whole thing about the project was, they want the biofuels, they don't know how to source it. They want a local, domestic supply biofuel that's collected from the doorstep, produced at a centralised facility, which then can produce a liquid biofuel, which can be then sent to these glass furnaces to decarbonise them. But they don't know what biofuels they wanted, or what centralised facility they wanted, or anything like that. So it was a huge collaboration piece between the Tyndall Centre, University of Manchester, Aston University, and Supergen Bioenergy Hub. We also packaged together this collaboration with Glass Futures along with 2 other industrial projects, and we won the Making a Difference Award last year. So thank you again to Joe, D'Angelo, and Catherine from marketing. They were really helpful with putting that together, so thank you so much to them. So here's what I first did. Mapped each of these furnaces that they had. You can see that they're kind of clustered in certain areas. There's a chair. You can see there's a nice little northwest cluster there, and there's a nice little Humber cluster there, tiny little one there, and then one up in Scotland. Just by looking at it in the data, you can see that there's potential for clustering these facilities together. But the question is, how do you cluster them, and what sort of ranges do you do? Looking over to these maps here, I started off by not clustering them, putting a sort of biomass search area around them, saying, what sort of biomass availabilities do we have to each of these concentric rings? And it's a bit more than you think. This is individually, but then as we went through the project, we clustered a northwest cluster, a Humber cluster, We got rid of that one because it was too small. And then we've got a singular facility up in Scotland. On the previous slide, you saw that there's a variety of options available for these facilities. Even though this little DSF, too small, too far away, biofuels may not be an option for them, so another option we have to evaluate for them. But the rest, perfectly sound. That's not showing up. Oh, no, that's half the diagram though. Okay, so what we used was a model that I created in my PhD called the Carbon Navigation System. It is a digital twin of the UK CCS and freight networks. If you don't understand that, it's kind of like a virtual version of the UK with all of its roads, rail, pipelines, shipping, everything in there. You can automatically switch between that. It's one-to-one geo-reference, virtual version of the UK, where you can build and design supply chains in there and assess them. It's really handy for that. Again, I wish that diagram was there. If you want to learn more about the full diagram, there's a great policy piece there we did with Tyndall Manchester, worked with them, they're great. I wish that was there. So it's basically, what you do, there is a green part of the diagram over here, which is the sort of biomass limb. There's 4 limbs of the model, each sort of tailored towards a different aspects. So you have a facility, and you have a virtual version of the UK that is specifically tailored to a biomass sourcing. Big green diagram there. There's also different limbs for it. There's a virtual version that's specialised for gathering and moving CO2. There's one for hydrogen, and there's one for energy output, be that a biofuel or a power. What you can do is that you can customise your supply chains to build them. Again, I wish it was there. To build these sort of supply chains, you can apply it customizably to any sector. It was built for bioenergy, carbon capture and storage, but can be reapplied to any sort of sector, industrial supply chain. Again, you can read more there. So, from those concentric rings that I showed earlier, within the model there is a biomass repository, which is a high spatial resolution data bank of all of the biomass production in the UK, down to the plot of land resolution, as well as a database that's linked to it, where the demand for that biomass resource is as well. So you can go down to the plot of land, know exactly how much biomass there is, where it is, what's the competition for it, how much can you build with it. You can build these sort of supply chains there. So you can see I've clustered them here, Scotland, Northwest, Humber. Lots of different biomass profiles there, which kind of allows you to choose what sort of biofuels you can create that are locally sourced around your facilities. Scotland, no surprise, large forestry sectors around there, so it's predominantly around that. Northwest, it's largely animal residues, animal waste, and industrial waste. Very poor cereal crops in the Northwest. Whereas if you move to the Humber, it is much more cereal crop heavy, some livestock waste, very little forestry in those areas. And these can help you with these numbers sort of evaluate and say, these are the sort of quantities of biofuel that you can produce. I have to apologise, there is an NDA on this collaboration piece here, so I'm trying to show you as much as I can. A lot of the specific numbers are locked away. So I can't tell you which biofuels we picked and they chose and they're testing, but it's there, so I apologise for that. So, last slide here. Again, I wish I could show you how to use an AI diagram just to show the sort of results there. It's all hidden away by the NDA, but we designed 3 industrial clusters with a centralised biofuel, liquid biofuel facility supplying these 3 clusters. Really interesting bit of analysis into determining that. Say if you have a really big glass furnace in the north and then 2 small ones in the south, where do you place your centralised facility to be able to feed these 3 facilities? Do you go a bit closer to the big one, or do you go closer to the 2 smaller ones? There's a lot of difference there, and we did, it's called a macro energy system analysis, where you can simulate these supply chains in these areas. In one place, you move a meter to the left, resimulate a meter to the left, repeat, and you get these sort of heat maps of these areas, where you can, so if you place your facility, centralized facility there, you get this cost, these carbon values. You can compare areas and give them options. Because we can say, this is the best spot for your facility, but if there's issues in getting that bit of land, you have 200,000 other options available to you in your area. So it can really help build a business plan together. So what we did there, so it's all tailored to the local biomass. I can't say which biomass they chose, but they're now testing it. It's being done with labs from Aston University. They've run it through, it's all dandy right now, but it's now being submitted to then BAYES, it's now DESNES for evaluation. So these are going to be quite large-scale clusters in the UK, one around Northwest, one around Humber, one up in Scotland. and again, the little one that needs to reevaluate. But based on that and the other projects I've been on, there's a bit of an issue around when we were talking to these industrial partners for this sector and other sectors, is that they're assuming that there's enough biomass around them, which there technically is. We talked to somebody, some of the cement people, and they said, oh yeah, we're looking into getting some biofuels to be able to decarbonise our sector. We'll just use what's around us, no need for a study on that. They're just assuming that there is enough around them, even though there is, but the sort of competition between sectors and within sectors will greatly diminish how big you can get these facilities to go, because you're kind of competing and eating against each other. So it's a real issue that we need to tackle, but the quicker you act, the better you can get your procurements of these biomass types to be able to decarbonise. So if a lot of projects are saying, we want biofuels, act quick, because everyone's going to snap them up quick. Thank you very much. Again, sorry for that.
Yes, actually touching the last point, actually, which I thought was quite interesting, because you pointed out biomass and biofuels are a feedstock for many different industries. I was going to ask whether, just to future-proof the industry, any scenario analysis has been done, but not only at a feedstock level, but also at policy level, because it could be like in a few years' time, where one of your competing industries is actually at the top of the government priority in what that looks like for the glass industry.
It is really interesting that it's. So what was your question there?
Oh, sorry. So if there is any scenario planning in terms of future-proofing the industry.
So I offer this. We've got a sort of business plan that we send out to these industrial partners with like a menu of analysis we can do for you. It's kind of structured in a baseline and then plugins. So we do the baseline, all this was baseline, and then we give them options for like future scenarios for what happens if a heat wave comes to certain areas and not such supply. What happens if you are integrating decarbonised fuel? How does that change your whole setup? They don't choose it because from what we understand is that we have very strict funding to be able to get these projects with us. And if we go for an extra bit, they say that's going to cost us more and they choose away from that. So we need to be careful in what sort of how we package and present this analysis. I think we're going to change it in the future and integrate these into the baseline. So just from the get-go, you're getting everything plus your sensitivity analysis. Right now, they're kind of just picking the basic one.
Yeah.
Hi. Can I ask?
Yeah.
How do you know that this is sustainable and low carbon? Like, how do you measure that? So, like, if you're using biofuel, a first generation biofuel, how can you be confident that this is actually better than the alternative baseline?
Yeah, that's a great question. So it's a bit of a mixture of where you're getting biomass from and what's the end use of the biofuel. So we kind of know the end use. It's the sort of glass facility. It's quite nice. It's located in one area, but the sort of embodied carbon into the different types of biomass. Say if you're comparing a municipal solid waste versus maize in a certain area, there's completely different body carbon in that. So that is baked into the analysis when you are building this. I wish that diagram was all in there.
So that's what, like, the carbon savings?
It's all built into it, yeah. So within the model, the whole model is basically built out of points and lines connecting them, all georeference certain areas, so you can measure exactly one-to-one to the UK what your emissions are going to be, and then you can bake in these extra costs for each of the different types within each of these data points in the analysis. So you have to consider these, and you can compare different sites again. So say if one area's got really good embodied carbon for biomass, then another area could have a really poor one, which then could supply, like the Northwest Cluster one that we said, it's got better embodied carbon, and the Humber one a bit worse. So it's all in the analysis. If you want to learn more about that, there's a QR code to the report. It's all
Just
in there.
ask, like, where does the data for the embodied carbon in the biomass come from? Is it from EcoInvent? Is it from?
EcoInvent, you got it in one.
Yeah.
So on top of that, do you know the scalability of it? So say if they chose like crop-based biomass and they wanted to expand their business further, and then you would obviously then have to have more land to produce the energy. Does that take into account those processes as well?
Yeah, so the biggest limitation of digital twin models is that it's kind of a snapshot in time. So you know exactly what you are right now. We're now working on expanding this, but right now lots of these businesses are kind of saying, what can we do in the next 5 years, which is kind of what their baseline are. But you can expand the model. It's got every single biomass type in the UK in there, apart from 2. it's energy crops and then used cooking oil, because used cooking oil is so poorly reported, you can't get any numbers on them. But you can build out these sort of areas with energy crops if you like, but there's huge land use changes that you have to consider there. But then, say if you're working with a facility, they pick a scale, they want to expand, you can reassess and reevaluate this supply chain with the new competition that may arise with there. Because say if you build a facility at one time, you say I want to expand, by the time you want to expand, another sector's probably come in and it's eaten up some of that biomass. So it's all about that timing as well.
There's some questions at the back. Lady with the black top. Yeah,
That's
you.
me. Just about kind of some of the assumptions in the model. Is it assuming that energy demand will kind of stay the same for the furnaces and that there won't be any technological improvements there? And then secondly, that glass kind of creation will kind of be business as usual, or is it pursuing a growth area, or just a little bit more information on that?
Oh, that's a great question, I love it. So we were told pretty strict guidelines into what sort of analysis we were going to do for the project. We kind of just, we were told basically to say, assume that it's business as usual for these facilities. How do we keep it going? But swapping out your fossil fuel for your bioenergy. We're producing the same, the demand's the same. There are other projects working with glass futures, potentially around the university as well, who are looking into those other blocks of demand reduction, changing into the chemicals, changing into the materials you use, carbon capture. It's going to be huge for the sectors. Luckily, the clusters that we designed are located in nice locations which are going to be productive in the future. It's right next to two of the UK's carbon capture clusters, which Dermot's going to talk about later, right next door to that. So there's good future proofing in there for them, but a lot of the analysis kind of goes, do you know those blocks that I showed? There's biofuels, hydrogen. You can kind of build combos. So you can have a glass furnace with biofuels and carbon capture and storage, be able to decarbonize even more. I wouldn't go more than 2 per project, but can really synchronize and synergize these strategies together to kind of future-proof.
There's someone going at the back there.
Thanks. I understand you've got an NDA, so you probably might not be able to answer this, but I suppose my question is about what's the source of the biofuels, because if they are from waste, then that sounds fine. If they're not, then that could have real significant impacts, not only on biodiversity, but also on the whole debate about energy crops versus food crops, climate change affecting your planting needs, the variations in soil, variations of all sorts of things. So I think it's quite a lot.
Yeah, no.
Questions there.
Yeah, I love it. It's great. We don't touch it. We only go for agricultural residues, industrial waste, any sort of waste residue. Gen 2 is what we're going for. We don't touch forestry, like growing forestry for that. We do touch the sort of clippings, trimmings, managements, those little excess. We do collect and manage that, be it from sawmill residues, paper pulp, what have you. It's not directly, we never grow crops for energy. It's all what do we have now, what can we build? So we're kind of avoiding all of those sort of side effects, which again really detrimental, so you have to be careful with that. I saw a presentation the other day where global demand for energy crops is going to skyrocket, which may have, like I said, huge biodiversity and land use change implications, which we're not touching, we're avoiding by using what we have now, but then the competition for that. So say if we are taking winter wheat straw from an area, right now that's being used to spread on land. A lot of there's great analysis out there to say, where surveys with farmers to say, what percentage of your wheat straw could you sell for us for energy generation? We've got those sort of numbers integrated, but again, you are stealing, or you're buying biomass from another distant use. So it's a huge sort of dichotomy there of, we're decarbonising here, but we're going to make it a little bit worse over there. So it's a bit of a balancing act. Nothing's going to be perfectly sustainable, you can just make it better.
I think we can take one more question. Yeah?
Hi Muir, thanks. Good presentation as always. So maybe my question is, like, while you're working with the industrial partners, so you present them with some options of which they can take. And how do you make sure that the option they pick, okay, is more environmentally friendly and also in line with the climate policy, if you say, or the mitigation action, rather than them picking up an option which is like less. So it's like you present 5 options and they will pick the cheapest one, but the cheapest one might not be which is good for climate action. So how, like, maybe you can see it as an ethics or a moral question since you are a researcher. So how do you make sure that it doesn't happen?
That's a great question. So the sort of crux of that whole issue with the menu supply, so we have all the analysis we can offer for your supply chain. We've got the baseline, base one. It's all about the time and the number of days. They want to pay for as little as possible. So you can fudge the numbers a little bit to where if you go, this project really needs this adaptation analysis on there. So you can then fudge your numbers to say, look, the same days, put it in, get it for them. But it's all about whether, if not, the project's going forward as research or as it consultancy, can really change how much you can do for them and how much they want from you. And of course, an NDA can go against you. But again, ethics for that. I stay away from that. I do the analysis. But it's something that's, I'm stuck in the numbers. But I will consider that. Like I said, we're going to try and rearrange this whole menu thing because it's all about giving them biggest bang for buck for the least amount of money. But again, we need to future-proof these sort of analysis for them.
Thank you. Thank you very much.